Hi, welcome to Mrs. Park's Algebra 1 class, Chapter 9, Section 2, Solving Quadratic Equations by Graphing. So I know 9.1 was a very long lesson, but this one will be a shorter one, I promise. Alright, so why do we do this? Thornton Arena at the Stage Fairgrounds in Raleigh, North Carolina has a shape created by two intersecting parabolas. The shape of one parabola can be modeled by the equation y equals negative x squared plus 127x, where x represents the width of the parabola in feet and y represents the length of the parabola in feet. Okay. The x-intercepts of the graph of this function can be used to determine the distance between points where the parabola meets the ground. Okay, so when you have these parabolas in real life scenarios, okay, you can use the equation to solve for x. To solve by graphing, a quadratic equation can be written in the standard form ax squared plus bx plus c equals 0 where a is not 0. To write a quadratic function as an equation, replace y or function of x, f of x, with 0. Recall that the solutions or roots of an equation can be identified by finding the x-intercepts of the related graph. Quadratic equation may have 2, 1, or no solutions. Okay, so when you have a graph, what they're saying is you put it in this form where it equals 0, solve for x, okay, and that's what we're doing, just solving for x. Now when you solve for x, there may be situations where you have 2. When we're solving for x, we're saying what's the x-intercept, what does it mean? Okay, so this has 2 places where it meets on the x, so you have 2 answers for your solution. When you see a graph like this and it only meets at one point, okay, there's going to be only one answer for a solution. You also have a graph where it doesn't touch the x at all, then it has no real solutions. Alright, so 2 roots. Okay, so here's the equation. Okay, so for this parabola, the function is x squared minus 2x minus 8. If you put it as equals 0, that means where does it meet on the x when y is 0? So you solve for x, and here you have the graph. Okay, so if you're looking at the graph, these 2 points, okay, where x is 0 or y is 0. So this is what, negative 1, and this is 2, 3, 4. Negative 1 and 4, negative 2 and 4. Okay, so those are your 2 answers. If you want to check your answer, you can put negative 2 here and here, see if it equals 0. And you can also put the 4 here and here and see if that equals 0. If they do, that means your answer is correct. This solution has 2 distinct numbers, so the 2 roots are the same. So sometimes the 2 roots are the same number called double root. Okay, and we'll get to that soon. Alright, so go ahead and solve 1a and 1b. So you're graphing this function, okay? Do you remember how to graph from section 9.1? If not, you can go back to the video or go back to your textbook and see review on how to graph a quadratic function, okay? So once you graph this, where it meets on the x-axis, okay, when y equals 0, those are the points that we're looking for. So go ahead, pause the video, and go to 1a and 1b. Alright, double root. Here's what we were talking about earlier. Okay, so when you have an equation, first of all, it's not equal 0, so you need to make it equal 0 by adding 9 to each side. When you do that, here's your equation that equals 0. Alright, so you graph this, and again, you need to graph this by finding the axis of symmetry, which is negative b over 2a. Okay, and you find this point, this line of symmetry, and your vertex, you put this as your x, and you find your y. Okay, there's your vertex. Your y-intercept is positive 9, so there's your positive 9 here, and there's your graph. Okay, so once you graph it, you see there's one point here, okay, and that point is 1, 2, 3. So the solution is 3. There's only one solution. So this is what we're talking about double root. When there's one solution, it's called double root. If you want to check your answer, put the 3 in here. 3 3 here and 3 here and see if it equals 0. And it did. So your solution is 3. Okay. So go ahead and do 2a and 2b. Okay, remember, graphing, it has to go equals 0. Okay, so move this around to make it equal 0. Once you do that, find the axis of symmetry. Once you find your axis of symmetry, put it in your equation and find a vertex. Okay, once you find your vertex, you also need to use your y-intercept. Okay, and then connect those points, make it a smooth curve, and then find what your x's are. Okay, so go ahead and pause the video and do 2a, 2b. Alright, welcome back. So here's example 3. Here's a third scenario where you don't have any and no real solutions, where it doesn't touch the x at all. Alright, so again, you write it in standard form. Okay, and you graph this, and once you do, you graph it, and you see it doesn't touch the x. The solution is an empty set. There's no real solution. Okay, go ahead and do 3a and 3b. So as I promised, it's a short lesson. So when you're done with that, make sure you put that back in your book bag and hand it in for homework credit tomorrow. All right, thanks for watching.